Hello, everyone, and welcome. My name is Raffaele Saggino. I am a senior infrastructure architect for Intesa Sanpaolo. Today, I want to thank you for coming, and I want to thank Ververica for having us. We are really happy to meet the Flink community for the first time in person. Today, our company has two presentations in this room. The second one will be after us, where we will go a little bit into also the details of what we will describe in this first presentation. A few words about me. I designed the first Intesa Sanpaolo streaming infrastructure. I am specialized in distributed and event-driven solutions. I'm also currently the project manager of the serverless and batch layer projects, renewal project, which is also part of the reason we are doing this presentation today.
So hello everyone, my name is Fulvio Pascotto, and I've been a developer and architect for more than 20 years now. I'm in Intesa Sanpaolo since 2017, where I have sponsored and contributed to design and bring to life streaming architectures of the company, along with my colleagues that are here today. Right now, I'm the data architect tech lead and the product owner of the framework Scrat that we've designed to help developers in the company to build Flink applications. So let me tell you more about our company. Intesa Sanpaolo's group is the leading bank group in Italy and one of the main in Europe. In fact, as the end of September, we are the first bank in Europe by market capitalization with 70.2 billion euros. Some more numbers, we have 21 million of customers. We have more than 4,000 branches in Italy, nearby 94,000 of employees. So you can say we are a big company. A few words about our mobile app. The Intesa Sanpaolo mobile app has been named the Global Digital Experience Leader by Forrester for 2 years in a row, out of 27 banking apps across 10 countries. So the app has 2 billion logins per year, and it's one of the finest banking app for features and user experience. So we are very proud of it. And in 2023, a new company in the Intesa Sanpaolo group has been created. It's called EasyBank, and ISY stands for Intesa Sanpaolo for you. And it's been created to compete in the fintech ecosystem. So the new company core banking is cloud native and is full event driven. So here comes the need for a strong process streaming architecture, along with our journey to the cloud.
To give you some context, we started our streaming journey in 2017 with the mainframe offloading project. At the time, we were using Apache Kafka, Apache NiFi, and Apache Storm. Kafka was, of course, to buffer the data, NiFi for light transformation, and Apache Storm for the heavy lifting. Okay. At one point, after a few years, we started to notice that we needed better guarantees, better processing guarantees, and we started looking at various options. One of the ideas was, for example, to use Storm Trident APIs, which allow us to apply exactly once processing. One other option was to use Twitter's the Twitter evolution of Storm, which was Heron, Apache Heron. I don't think it actually went that well. And Kafka Streams. So we tested several of these solutions: Kafka Streams, Samza, Apache Spark Structured Streaming, and Flink. If today we are here is because one of them won, and of course was Flink. And the reason, aside from being first in streaming solution, is also that Flink allowed us, possibly in the future when we needed, and this time is actually coming, to use batch processing. Okay. So back to the slides. In 2021. Intesa Sanpaolo signed a memorandum of understanding with Google and TIM, which is a telecom provider in Italy, the largest one, to build 2 regions, one in Turin and one in Milan. Google Cloud didn't have any regions in Italy before that. We are currently going towards what we call a multi-hybrid cloud solution, which means that we want to use both on-premises and cloud, and actually we have to due to regulations. The project to move the bank to the cloud or to migrate the workloads is called Skyrocket. So I will just talk a little bit about how we are made. So we have on-premise, we have in total 4 data centers, 4 main data centers, 2 in Turin and 2 in Parma. And for the sake of this presentation, I will call them on-premises regions, okay? Then we have 2 other regions, cloud, one in Torino and one in Milano. And of course, we are open for a second cloud provider, since, as I said, we are looking for a multi-cloud strategy. Okay, this is proof that, by the way, we are among the things we are doing. Of course, at one point, we decided that it was time to move Flink to the cloud, and 2024 was the designated year. So actually, one of the images was made by me, the other one by Fulvio, and Fulvio liked it more, so we kept it. Thank you. Regarding the on-premise infrastructure, regarding our infrastructure in general, we use Ververica platform. Okay, so we are Ververica platform users. The platform runs on top of OpenShift, and as you can see, we have OpenShift. We use the Postgres for the database layer, and then we use an S3 appliance for the state backend. Now, for high availability reasons, the OpenShift cluster is stretched between 2 sites, 2 availability zones, if we want to call them in the cloud naming, on 2 sites that are far, if I recall correctly, 25 kilometers apart, 20 kilometers apart, more or less. And the database, it's also replicated synchronously to the other site, asynchronously to the other city, so the other region, which is 200 kilometers away. And this is a bit different. The S3 backend, the appliance, it's replicated synchronously due to the same constraints to the other region. This actually led to a few interesting issues, and we had to tune our jobs to work in this way, okay, to accept the latency of the synchronous replication. One important thing to say is that our job lifecycle is based on Bitbucket, Argo CD, and Customize. All the data relevant for the deploy is on Bitbucket. To bring Flink to the cloud, we built a similar infrastructure. So as you can see, a few key differences that I hope are clear from the slide are that we have, instead of 2 sites, we have 3 sites, 3 availability zones on cloud, and OpenShift spans all of them. We rely on the blob storage solution from the cloud provided by the cloud vendor, and in this case is Google Cloud Storage, and which is synchronously replicated inside the region and asynchronously replicated to the other region through a storage transfer job. Both solutions, the cloud one and the on-premise one, are made in this way to be able to test the disaster recovery scenario and allow for a downtime as short as possible. Actually, as a bank, we need to prove that our downtime is under a few hours in case of disaster recovery, and this configuration allows us to do it. Now, I believe that the most important part of this process is the migration one. So how can we move from our on-premise solution to the cloud one? The way we designed it is described here, but essentially we stop the Flink job. If it's a stateful job, we will take the latest save point or checkpoint. We will remove the destination from on-premises or on Argo CD. We will transform the YAML from an on-premises solution. So we will switch the endpoints, for example, for the S3 for the bucket storage, from S3 to GCS. Then we will set the correct GCP destination on Argo CD. And one thing that I want to underline is that we needed something to attach a save point to a job. Okay, there was no such thing for us on Ververica platform. We asked the Ververica guys to build it, and they actually did. So now we have an API with which we can attach the save point to the job, and when the job will run again, it will restore from the latest save point. Then the last two steps are starting the job actually in GCP, checking that it works, and updating the internal inventory. Now, I would say that we can move to the batch processing side.
Yeah, so what about batch processing? Of course, as a bank, we have tons of batch processes to manage, and we have to think about them in our journey to the cloud. By the way, this is how generative AI pictures batch processing. And take a second to look at it. I think it's pretty accurate, in my opinion. It's what I visualize when I think about batch processing. So anyway, how we are made now, how our jobs are made now. A big part of our jobs, of course, are in the mainframe architecture. And there is a lot of legacy code, and it's becoming very hard to manage and to scale efficiently, given the amount of data that is growing constantly, and the speed that the regulation requires. So also on the mainframe, the resources are very limited. On the other side, we have the open architecture, where there are lots of virtual machines packed with many applications that share resources and obviously don't scale horizontally. And also there is no really standards in the implementations, and the monitoring is hard and is left in the hands of the development team. So what options do we have to migrate these batch jobs in the cloud? Actually, the first option is to lift and shift the virtual machines to the cloud, and probably that is the easiest in terms of effort and the best option to be up and running in really no time. But we will have the same problems that we had on premise, plus the cost surely will rise. So can Flink come in our help? Sure. So with Flink we can achieve horizontal scaling, workload isolation. We can have a standard approach in the development with our framework Scrat that our colleagues will talk in the next speech. And we can achieve scale to 0. We can have a built-in observability framework, so we can feed our monitoring systems. And we can think of hybrid scenarios like mix and match stream processing with batch processing. Okay, so Flink can help. So far, so good. So this allows us to rethink the way that we build our batch process. Flink gives us new opportunities. We can, for instance, spread our batch processes during the day, so we can avoid peaks of resource usage in specific hours. We can feed data lakes in real time to open new use cases that we haven't think before. And we can think of different paradigms like the serverless and build real data-driven architectures. So that's it.
Yeah, one more thing I would say is that the link between the two things is that while we were moving to the cloud, we had to understand what was the purposes of batch jobs. Okay, so we had to understand what we do with batch jobs in the company, and think, okay, can we move them to a streaming solution? Do we have to keep them as batch jobs? Can we possibly in the future make these batch jobs streaming? And so this is where Flinks come in, actually. So we might, at one point, bridge this gap and have a full solution for us, okay? Thank you.
Thank you. Any questions?
Great journey. And I've heard that you used NiFi, right, for
Yes.
ingestion of the data. And now, do I understand correctly that you replaced that with pipelines in Flink, or do you still run NiFi to do the ingestion?
You want to answer?
We still use NiFi, but in the long term, we will replace it probably.
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 Well, NiFi does also some orchestration more than Flink, in my opinion. So they are not replacement for one another. We did use NiFi mainly for the mainframe offloading project, a copy banking project. And in that case, yes, Flink, I believe, is much better. But if you do orchestration, I don't know how much Flink fits the pattern.
And do you use Flink SQL in the setup to democratize the access? Or
Not yet.
Not yet.
Not yet.
No, we are thinking about it. We currently use other kind of tools, for example, KSQL. But I do believe that Flink SQL is very interesting for the future as an alternative. Thanks.
Thank you.
Hi, thanks for the talk. So this is a question about your migration from on-prem to cloud. I'm not sure if I missed anything, but is it because your downstream app is not idempotent that you had to stop the Flink job first? Why not just save point and take some reprocessing?
So we decided, for safety reasons, essentially, we decided to stop the Flink job first. It's not like we couldn't just reload it on the other side and reload it in an easier way. But this is the first reason. The second reason is that the process is fully automated. Sorry, I forgot to say that. That's very important. But the process is completely automated. And if you wanted to do something more complex, then probably you will need some manual checks or a more advanced automation. Thank you.
Got it. Thank you.
Any other questions? Okay. Thank you very much.
Thank you.
Have a nice day. Bye-bye.